Hello, welcome to another episode on Hands on Mac. So in today's video, we're going to see about how a fuel gas system is designed for a gas turbine power station. So as you can see, this is a main gas supply line. This could be anyone. So for our requirements, for our plant requirements, we are going to tap into this existing line. To tap into the existing line without isolating this line is known as hot tapping. So hot tapping is a process of tapping into the existing line when the line is in service. The only thing what we do is that the service provider of the gas, the main gas supply line, will reduce the pressure, and then we will be cutting and welding on the existing line and putting a valve on it. So that process is known as hot tapping. I will be making a video how the hot tapping process is done later on. So just for now, just remember that the process of hot tapping is to cut an existing line and put a valve there. As soon as the hot tapping is done, we will put a valve there. As soon as the valve work is completed, we will route the line and then we will put a valve which is known as ESD, which is known as emergency shutdown valve. So why the valve is provided here? In case of any emergency in the gas plant or for the gas turbine, if we want to shut down the entire gas network from the control room by using the remote operations, they can close this valve and they can shut off the entire gas system. At the same time, the control room can open this vent line and then vent out the entire gas from the system to a safe location. So that's the purpose of this remotely operated emergency shut-off valve and an emergency vent valve. So that's the purpose of it. As soon as the gas comes out of the ESD station, it will be routed towards a tariff metering station, because we need to know how much gas we are consuming, or the provider of the gas supply line or the supply company needs to know how much gas the consumer is consuming. For that, we will be providing a tariff metering station. So the tariff metering station will measure how much amount of gas the customer or the consumer is consuming to operate this gas turbine. So as you can see, this is a tariff metering station. This is a 2 isolation block valves for this fuel metering station, and I have shown here a bypass valve. The purpose of this bypass valve is to bypass the tariff metering station when the tariff metering station is undergoing some kind of maintenance. So we don't need to shut down the entire gas station because the tariff meter station the flow meter have some maintenance works. So what we will do, we will open the bypass line and then we will isolate this fuel metering valve, fuel metering device, and then we can run the station through the bypass line. As soon as the maintenance is completed, we will be opening these 2 lines and we will be isolating this line and taking the tariff metering station into service. In a typical gas station, there will be vent points provided at several locations to vent out the gas to a safe locations in case of any maintenance works or any other plant requirements. So after the tariff metering station, the gas goes. Before it enters to the gas and main gas plant, there will be a device or an equipment called a drip barrel. Drip barrel is normally located underground. The purpose of drip barrel is to take out the condensate from the natural gas. So this will enter into the drip barrel. The drip barrel will be provided with sufficient level indicators, level transmitters, level switch, which will be wired to this drain valve. So if any of the condensate level goes high, the auto drain valve will be open, and once the level goes down, the low switch will act and it will make the valve go close. So this drain will be routed to a safe location, because since it is a gas condensate which is considered as highly inflammable, so this has to be routed to a safe location. As soon as the gas exits the drip barrel, as I have told before, the purpose of a bypass valve, you can see I have shown a bypass valve for the drip barrel as well. So in case of any maintenance for the drip barrel, you can simply isolate this and open this and take the gas to the gas plant by passing the drip barrel. So as soon as the maintenance work is done, you can normalize the drip barrel and take this drip barrel in service, and you can isolate this bypass line. As soon as the gas exits the drip barrel, it goes to an equipment called scrubbers. Scrubbers are mechanical separators which will take out the gas heavy particles from the gas by the principle of vertical cyclonic separation. So as soon as the separation is done, all the heavier particles will be accumulated at the bottom side, and then the light gas will be going out of the scrubber. There are two scrubbers provided, and I have mentioned is 100%. 100% means this one scrubber is enough for the entire gas plant and for the gas turbine. That's why I have mentioned as 100%. So this, as you can see, this scrubber is also provided with the level indicators, level transmitters, level switches, and this will be wired to a control system. In case of any condensate development or condensate formation, it will send a signal to the drain valve, and the drain valve will be open, and all the condensate will be going or taken out to a safe location. As soon as the level low switch acts, this drain valve will go close. So that's the purpose of the control system for the scrubber. And the equipments provided in the scrubber will be level indicators, level transmitters, level switch, high level switch, low level switches, etc. As soon as the gas exits the scrubber, it will enter filter port. You can see two filter ports provided, 1, 2. Let's say 2 into 100%, which means this is also 100%, this is also 100%, which means this one filter port is sufficient for the entire gas plant to operate. No, sorry, for not the gas plant, for the entire gas turbine stations to operate. So these are the two filter ports. Filter ports are also provided with the level indicators, level transmitters, level switch high, level switch low, and the most important is the DP indicator, because it is a mechanical filter. It is a filter element. So as soon as the filter element have any kind of DP, the control room will get an alarm, and if it exceeds the limited value, you have to open the next standby filter and take it to service, and you have to isolate this for maintenance purpose. As soon as the filter is replaced, you can take this, you can purge it and take the filter ports into service if it is required, or else keep it isolated unless and until if you don't have any issues with the other filter port. As soon as the gas exits the filter ports, it goes to the gas compressors. Okay, before it goes to the gas compressor, a small portion of gas will be routed towards a device called gas chromatograph. Gas chromatograph measures the hydrocarbons present in the gas, which means it will measure methane, ethane, propane, butane, pentane, hexane. All kind of hydrocarbons will be measured by using gas chromatograph. Why we need to measure the gas? Because the OEM of the gas turbine have some specified, gas quality which needs to be maintained for the combustion. So we cannot just put any gas quality, any quality of gas into the gas turbine. It has to be as per the OEM specified gas. To know that, we are using a device called gas chromatograph. Gas chromatograph will provide you with the exact gas quality. Soon after, as I mentioned before, soon after it exits the filter ports, it goes to the gas compressors, where the pressure will be boosted as well as the temperature also will be boosted of the gas. So gas turbine have some specific pressure and temperature requirements. All these can be maintained with the help of these gas compressors. Before the gas enters the gas turbine, a final filter is provided where it will be filtered to the OEM specification before it enters to the gas turbine. So this is the gas compressor. Soon after the gas compressor, there will be a final filter where the gas will be, most of the stations may have this final filter. Some power plants I haven't seen this kind of final filters there, but most of the gas turbine power stations may have a kind of final filter. Right after the final filter, the gas enters the gas turbine, and there is the combustion occurs. So this is the entire simplified view of a fuel gas system.